Here is question number 11. A point source of light, it at a finite distance from source, produces plane wavefront, spherical wavefront, cylindrical wavefront, depends on the color of light. And we are knowing very well, a point source of light always produces a spherical wavefront at a finite distance. So, since we know that a point source of light at a finite distance always produce spherical wavefront. So that's why after looking at the options, we can say that we have to go with option number 2, which is absolutely correct. Now let us proceed to the next question, that is question number 12. So here is question number 12. If the amplitude of transmitted polarized light through a polarizer is A by 2, then the amplitude of unpolarized light incident on it is what? Now we know very well that the intensity of transmitted light becomes half of intensity of unpolarized light. So if I0 is intensity of incident light, then I0 by 2 will be intensity of transmitted light. We are knowing that the intensity of a light directly proportional to amplitude square. So here also the intensity of transmitted polarized light will also be proportional to its amplitude square. So we can write, therefore I0 upon 2 must be proportional to its amplitude, that is A by 2 square. And the intensity of incident light, that is I0, must be proportional to its amplitude A dash square. Taking the ratios, we get I0 upon 2 divided by I0 gets you 1 by 2 equals A square upon 4 times A dash square. 2 2s are 4, and you will get the value of A dash as A divided by root 2. It means the amplitude of incident light is A divided by root 2. After looking at the options, we can say that we have to go with option number 1, which is absolutely correct. Now let us proceed to the next question, that is question number 13. So here is question number 13. A small aperture is illuminated with parallel beam of light having wavelength lambda equals 942 nanometer. If the first minima is formed at an angular position of 1.5 degree, then what will be the size of aperture? We have to calculate the size of aperture actually, and we know very well the condition for minima in Fraunhofer diffraction by a single slit is given by A sin theta equals n lambda. This is the condition for minima, or you can say dark fringe. Now here it is clearly mentioned that this is the first minima, so in case of first minima, we can write n equals 1. So therefore expression will become A sin theta equals lambda. Now we know very well for a small angle sin theta approach to theta, therefore expression will become A times theta equals lambda. Now let's plug the values from the question into the given expression. We can have A multiplied by theta is 1.5 degree, so we better to convert it into radian. Pi by 180 equals lambda, that is 942 nanometer. So 942 into 10 to the power minus 9. We will get the expression for A, that is 942 multiplied by 180 multiplied by 10 to the power minus 9 whole divided by pi times 1.5. After solving, we will get A, the size of aperture, as 36 into 10 to the power minus 6 meter, or we can write A as 36 micrometer. After looking at the options, we can say that we have to go with option number 2. Option number 2 will be absolutely correct. Now let us proceed to the next question, that is question number 14. So here is question number 14. The displacement of two interfering light waves at x equals 0 is given by y1 equals 4 by 5 sine omega t and y2 equals 4 by 5 sine omega t plus 2 pi by 3 respectively. What will be the amplitude of resultant wave? Now we know the expression for amplitude of resultant wave, that is given by under root a1 square plus a2 square plus twice a1 a2 cos of phi, where a1 is the amplitude of first wave, a2 is amplitude of second wave, and phi is the phase difference between these two waves. Here phi is clearly mentioned 2 pi by 3. So let's plug the values from data into the expression. We have a1 square, that is 4 by 5 square, plus a2 square, that is 4 by 5 square, plus 2 times a1, 4 by 5 multiplied by a2, 4 by 5 cos of 2 pi by 3. Four by 5 square plus 4 by 5 square plus 2 times 4 by 5 square multiplied by cos 2 pi by 3 gets you minus of 1 by 2. After solving, you will get the amplitude of resultant wave as 4 by 5. So after looking at the options, we can say that we will have to go with option number 3, which is absolutely correct. Now let us proceed to the next question, that is question number 15. Here is question number 15. In Young's double slit experiment, the intensity of light at a point on screen where path difference is lambda by 4 is I. The intensity of light wave where the path difference is lambda by 6 will be what? Now we know the expression for resultant intensity or intensity of resultant wave is given by 4 times I naught multiplied by cos square phi by 2, where phi is the phase difference between interfering waves. We know the expression for phi also. Phase difference phi is 2 pi by lambda multiplied by path difference. So in the first case, path difference is lambda by 4 and intensity is I. So we can write I equals 4 times I naught multiplied by cos square phi by 2. So we can write phi as 2 pi by lambda multiplied by path difference lambda by 4 whole divided by 2. After solving, we'll get 4 I naught cos square, lambda lambda cancel out, 2 cancel out, pi by 4, and after solving we get I equals 4 into I naught into 1 by 2, that is 2 I naught. Equation number 1. Now if the path difference is lambda by 6, then what will be the intensity? So let's call it I dash. Again 4 times I naught multiplied by cos square phi by 2. So here phi we can write 2 pi by lambda into path difference, that is lambda by 6 whole divided by 2. After solving, we get 4 times I naught multiplied by 2 cancel out, lambda cancel out, cos square pi by 6, which is equal to root 3 upon 2 whole square. Now 2I naught is I. So 4I naught will become 2I multiplied by 3 by 4. 2 2 ja 4. So I dash equals 3I by 2. We have to answer the intensity in terms of given I. So that's why we are doing all these things. So finally we got the intensity when the path difference is lambda by 6 will be 3 times I by 2, and after looking at the options we can say that we will have to go with option number 4. Now let us proceed to the next question, that is question number 16.